Hello everyone, my name is Harshita Amrit and today I'm going to present my project Machine Text Translation using Recurrent Neural Network. This project is a part of my pattern recognition course at University of Florida. Now machine text translation is the process in which the machine converts sentences from one language to another. And earlier statistical machine learning translation technique or SMT was used for this. Nowadays, the researchers as well as investors have a huge interest in neural machine translation. This is because the model applies deep learning. NMT requires only a fraction of memory needed by the traditional statistical machine translation models. Also, all the parts of the NMT model are trained to jointly maximize the translation performance. That is, they work hand in hand, keeping in mind the performance. And hence, we get better results with NMT. In this project, bidirectional RNN encoder and decoder are used. The main aim is to apply the global attention method and a hybrid character word model to improve the accuracy of the text translation. So, let me give you a brief introduction. A recurrent neural network is a class of artificial neural network where connections between units form a directed cycle. This means that the output of one node becomes the input of the another node, and henceforth. So, attentional mechanism selectively focuses on parts of the source sentence during translation. This helps in forming a very good meaning of the sentence and translating it to another language with the correct meaning. A hybrid system translates mostly at the word level and consults the character components for rare words. So this has the advantages of word level translation as well as character level translation, because mostly the translation is done at the word level, but in case of words which are not known or which are rare, we go for character level translation. So, in other research work going on, people use classifier-based text simplification model, which basically uses support vector machines and naive-based classifier. The biggest challenge in the process is to figure out the most relevant translation. That is, not only the syntax of the words is important, but also the semantics of the words is very important to get a useful meaning in another language. So in my project, I have proposed a model which has several parts. So the first part of it is pre-processing of the data that has been done in Python. I have written six scripts for doing this. The rest of the project is done in MATLAB. So pre-processing includes converting sentences to integers. So we know that the neural network would accept input in the form of only numbers. It cannot accept sentences. So first of all, we have to convert it into integers. And the word to vector conversion has been implemented from scratch. So the process involves, first of all, the words are stored in decreasing order of frequency and they are assigned a unique identifier. Now, SOS and EOS are used to demarcate the start and end of the sentence. For rare words, a character level LSTM is implemented. Now, LSTM is long short term memory model, which is very popular nowadays for encoding and decoding. So, this also has been implemented from scratch in the project. Now coming to the global attention model, the figure can be seen on the left. So first of all, the input is taken from below, from the lowest layer, and the second layer here is the attention layer. So as you can see, the blue nodes, so the blue nodes have been passed through the attention layer. That is, they are given more importance, and their meaning is collectively formed and then passed to the upper layer along with the red nodes to get the output YT. So this approach helps in forming useful meanings, and it actually inculcates the relationship between different words. Whereas in the hybrid model architecture given on the right, we can see that the input is taken as a word, and then it is passed letter by letter, that is character by character, to the second layer. And there we have the difference between character and word level. So if a word is already present in the system, it directly gets converted. But if an unknown character is present, then it is assigned a UNK character, and that is converted using the character level translation. And ultimately, on the top, we can see the conversion of the word being outputted. So now we can see that the sigmoid function is used at the gates in LSTM, whereas tanh function is used at the gates in LSTM hidden units. Based on the source representation, the decoder generates a translation, one target at a time. The formula for the conditional probability is given next, and this formula is used to calculate the cost function. Uh, the cost function basically defines the error which we incur at the end. So the previous wordplay plays a very important role in finding out the probability of the next word being produced, and that is calculated using a softmax function. So the formula for the softmax function is given here, and this again, as seen by the figure, we can see that when there is a relation between two words, that is taken into account using this function. Now the result part, before coming to that, I would like to tell that I use the length of the training data set to be 10,000 sentence pairs, and the length of the testing data set was 100 sentences in English, which was supposed to be converted in German. Now, a network, I tried out different networks with different number of nodes and layers. What worked out best for me was a network with 1000 LSTM nodes and 4 layers. Also, when I reversed the source sentences individually, it gave me favorable results. So the training took around 2 days to complete with an epoch set to 10, and the best result was obtained at 8th epoch with a learning rate set to 0.25. So the successful conversions were the word love was converted to Lieben in German and was converted to und, and similarly a sentence translation is also given. So as that can be seen, the verbs, adverbs, and conjunctions are interpreted correctly in almost all the cases. The proper nouns like names, places can be improved with better training data set. Now, the proposed model helped reduce error incurred by the encoder and decoder with the time it has been plotted in the graph. And as you can see that initially the loss incurred by both encoder as well as decoder was high, but as time passed and the number of iterations increased, the loss in encoder and decoder reduced significantly. Further, I calculated the BLEU score, which is a very popular method nowadays for comparing results between different research methods in the field of text translation. And so, first, I had tried using only the word architecture, and the starting of it with the low vocabulary size gave me about 2 BLEU score, and it increased up till 6 as I increased the vocabulary size. The best result was found when I used the hybrid architecture of word and characters. And as can be seen from the graph, it gave me a BLU score of 6 in the beginning itself and went up till 7 finally, as the vocabulary size increased. So on the right side, we can see that the previous models gave about 2 score, and using global attention method to those models gave me about 4 BLU score, and the best was when hybrid and global attention both were used together to get me a score of BLU score right from the beginning. So, in conclusion, I can say that it has been observed that the results of test improve significantly with more number of words, and the number of layers can be changed, and the number of nodes can be increased further for improvements. Further, the vocabulary size itself can be increased to more than 10,000 to get better results. Uh, and using a GPU device speeds up the translation process. So, these are the improvements which can be done in the future, and these are the references which I used. Thank you for listening to my presentation. Now I would like to show my demo. So, so now let me move on to the demo part of my project. So as you can see, the folder of my project contains three parts. One is the data, one is the MATLAB code, and one is the Python scripts. So in the data, I have all the data which I've downloaded from the Stanford NLP site, and the MATLAB code contains all the codes required for word to vector conversion, LSTM decoder, LS and encoder, as well as staining and testing files. Now, the Python script is something which is used for pre-processing of data, and this basically has make dictionary, generate module, generate vocabulary, convert word to integer, and reverse. So the pre-process data file contains the calls to all of these scripts. So let me show you what it is. So as you can see, it has commands to call all these and make the folder data.processed. So let me run this. So the pre-processing is starting. It is generating modules right now. It's making the dictionary, the character dictionary from all the words. Now it is converting the sentences to integers so that it can be taken as the input for the neural network. And finally, it is reversing the integer tuples because it was found out that it gives better results. So now my pre-processing is completed. Let me check. So as you can see now, a data.processed folder has been formed, and this contains all the files needed for my processing and training, and the ID contains the ID of all the sentences. So let me go to MATLAB and run it. So the MATLAB code contains training project files. So it takes as input the data which has been processed just now. So the training data set is taken. Out of that, the identifiers, so this is the ID training data set, and then again the IDs of the valid data has been taken, and the ID of the testing data. So my source language here is English, so it is denoted by EN, and my target language is German, which is denoted by DE here. Next, I will take up the vocabulary in English and the vocabulary in German. Finally, this is my output directory which I want to form. So this is training result which will get formed when I run this. And I would also like you to show the testing command. So the testing project is being called here, and the training results which was formed in the last training will be taken as input here, and the train data .mat is the module, train module, which has been created, which will be created after I run the training command, and testing results will be the folder which will be formed after the testing is completed. So the training usually takes about 2 days to complete, and the testing part takes about 15 minutes to complete. So after that is done, I would continue with this and show you the results. So let me do that. Now let us look at the results. So as you can see, now we have two folders after the training and testing. One is training results and one is testing results. Training results has the train data .mat inside it and train data recent.mat, as well as the log file. And the testing result has the align, char, log file, and output files. So the output file has these translations, and as you can see, some of them like ihre leben, love there, etc., have come correct. Some of them are getting repeated. So by increasing the vocabulary set and the training data set and changing the parameters, this can be improved further. So at last, I would like to thank my professor Wu Dapping for giving me the opportunity to make this project. And thank you all for watching.